So when we're trying to add two fractions, we can notice the denominator is very important. If it's the same, we're good to go. It's a fundamental, even when you're adding fractions with an algebraic form, you need to find a common denominator. So getting into a habit here is very good. The denominators we have are 4 and 15 in this example. And we want to think about a number that both of them go into. But a lot of the time, if you're really stuck, you can multiply 4 by 15 and find a common denominator there. You find a common multiple. That's basically what it is. It's not always going to be the smallest option. With 4 and 15, the other alternative, if you're really stuck, is to go up in your times tables, like so, in both, and consider which one is the quickest one that they both have in common. Now, if you think about the larger number, there's less multiples. It gets bigger quicker. So if you look at the larger one, it's easier to check if either of those divide by 4. And I think you could see that the smallest one is going to be 60. If we carry that on, we'll also get to 60. And you have what is known as a common denominator. Okay, so if our focus is on 60, we can begin by channeling that focus, if you will, putting a 60 as the denominator in both. We're adding the fraction, so that remains as it is. Now the question is, if this is 60, what have we done to get to 60? Well, there's a couple of ways of writing your notation. Some people like to use arrows to show what they've done. I like to multiply with a tiny little expression. Depends how small you can write. So I would have multiplied this 15 by 4, and I would have multiplied this 4 by 15. Okay, now I need to do the same to the top and the bottom. I can't just go around multiplying fractions. It would be absurd to have 7/15. If I multiply just the bottom by 4, I'm saying that 7 over 15 is equal to 7 over 60, which absolutely isn't the case. So I have to balance that fraction, and we multiply by the top as well. So we get times 4, and that's how we find our new numerator, which is going to be 28 on this side. And on the left, we do the same on the top. It's a really good habit to get into, to immediately say, right, top and bottom, same thing. I did a little explanation in between there, but if you get into that habit where it's automatic, it's much stronger. So 15 multiplied by 3 is our 45. And we're going to add these two together now. It looks like we may end up with a top-heavy fraction. So we've got 73 over 60. Now that's the method, because as soon as we have the denominators the same, it just becomes a case of, and I'll show you in two parts, it becomes a case of adding the numerators. Okay, so that's all we're doing there to get to that 73 over 60. However, 73 over 60 is not the format idea that we want it in, because usually we have a mixed number, and how we find a mixed number is to see how many holes it goes in. 60 goes in once, and then we're left with a remainder of 13 over the 60 that we're dealing with. You can carry on to simplify the fraction on the right, but it looks like we can't go any further. What was your indication that we couldn't go any further? Hopefully you noticed that 13 is prime.